Hey, look, it's me, John Park, and we're here again for another episode of John Park's Workshop. Thanks everyone for coming by. I am happy to see that we've got some good people over in YouTube chat as well as here in our Discord. This, by the way, is the Discord. Did you know? If you want to... oh, hey, look, I broke it. All right. That's not the Discord. That's just a weird mirror into our souls. I can fix that. Here, let's do it. Let's find that from that drop down. And look, there's the Discord. And what we're going to do right now is fix a whole bunch of other windows. Let's see if the others survived. So get ready for it. Adam, no, you broke. No, you're there. Okay, not broken. Oh, Chrome not broken. All right. Hey, better than I had hoped. Okay, maybe that was the only window that went weird. So far, looks like we've got some good stream health according to YouTube, but sadly, Andy Calloway reports that we've got audio out of sync already. So that's a bummer because I had just finished doing a bunch of stuff that I had hoped would fix some of that. But let's give it a little pause and restart. When that comes back in, hopefully it's back in sync. Let's see. Yeah, wee laggy. What the heck, people? I'm not sure that much changed other than everything. Unfortunately, there were OS updates and there were Wirecast updates. And who knows what the heck else. The actual bandwidth is great, which is the frustrating part because it's the easiest thing to test. But yeah, there we go. And now it says it's fixed, huh? All right. Well, let's get on with some stuff then while things are actually in sync, hey? And just let me know. I'll keep an eye over on the chat and let me know if it goes out of sync, and we'll do a little pause and restart. Okay. So first thing I want to mention is that we've got our jobs board. So if you want to go and look for jobs, then this is a good place to do it. It is jobs.adafruit.com, and that is the job board section of it right there. You can also scroll up and go to the available for hire section. That's how you navigate that, and there you'll see there's people who are offering their services. I'm not logged in right now, so it won't show me that. But that's a good demonstration of you got to be logged in before it'll show you the individuals available for hire. But anyone can go and access this section right here. It's absolutely free, so if you want to post a position such as exhibit maintenance technician at Discovery World in Milwaukee, Wisconsin, that looks cool. Have I looked at that one before? Let's see, that was posted on August 20th. The exhibit maintenance technician is a high-energy, fast-paced problem solver who's comfortable in a workshop as well as public settings. That sounds a lot of fun. So if that's your jam, go and check it out. It's a full-time position with the schedule being Wednesdays through Sundays, 8 to 4. Hey, sounds cool. And that's on-site in Milwaukee, Wisconsin. So go check out the jobs board and you might find something. All right. Let's see. What else is up? I've got this show on Tuesdays. It's called JP's Product Pick of the Week. And the thumbnail for this week's is right there. This is the recap we're going to do here. This is a 1-minute recap of what is otherwise about a 20-minute show where we dive into some of the operation and details of a product pick and great discounts during the show. So this week is 50% off for the Power Boost, and right now I'm going to give you a little 1-minute recap. Check it out. The Power Boost 1000C. It is a boost that takes your batteries from 3.7 up to about 5.2 volts, and it's a charger. I'm going to power a Raspberry Pi 4. I'm going to go ahead and run my little battery through the Power Boost through this USB cable into the C port there. You can see it's started booting up. Obviously, you're not going to run this for very long on this little battery. I would guess an hour or something on this little battery, but you could go up to a big chonker donker like that right there. This is the Lucio Blaster running that exact Power Boost 1000C. I integrated a little charging port here into the side. Then I have the enable grounded right now. If I flip this switch, it will turn on and supply power. And all of that is being powered by our Power Boost, the Power Boost 1000C. The Power Boost 1. Hey, let's bring that audio back in. Okay, I'm just going to do a quick goosing of the broadcast back in for you once it starts. I think so. I think that's how it works. So I won't say anything critical right now, but I'll get used to this, and then I think it's probably time to do either a reevaluation of the entire system. My fear here is that this is a Intel-based Mac, and updates to software and operating systems are headed towards M1 stuff, and maybe it's starting to break the old stuff, which is a shame. Yes, Doctor, I did restart, so hopefully that gives us another little fix to buffering and so on. And I'm just gonna pop over to, yeah, it says the YouTube widget says streams bitrate is lower than recommended. I have dropped the canvas and the output to 720p. I know this is more detailed than some of you want, but that is, yeah, it says that its streaming bitrate is way too low, but it shouldn't be. Ah, well. Okay, so moving on, let's jump into, optimistically here, but I am recording this in the background as well, so that I have something non-busted later to repost, because I'm going to jump into the CircuitPython Parsec. Let's check it out. CircuitPython Parsec. All right, let me grab that window. Where'd you go? Atom. I say atom sometimes, and people probably think there's a D there, and who am I talking about? I'm talking about this coding environment, ATOM, atom. For the CircuitPython Parsec today, what I wanted to talk about is list slices. What are list slices? List slices are a way inside of Python to talk about a subset of a list, and in this case, it's a really convenient way to cast one set of a list to the values of the same list in a different section. So, first of all, why are we doing this? I'm doing this to do this neat little rotating NeoPixel thing you can see here. I have a Circuit Playground Bluefruit, and I'm diffusing it. And what you can see in my code is that I'm bringing in time, board, and NeoPixel. I'm also bringing in my color helper class from my JP Colors module. Then I'm setting up the NeoPixels in the standard way. And now I'm setting the first, middle, and sort of last pixels. It's an odd number to do this with, but I kind of want a triangle. So pixels 0, 4, and 7. I'm setting those to cyan, magenta, and amber. Then in my loop here, I grab that color of the first NeoPixel, that's pixel 0, and I cast that to a variable called first pixel color. Then this is the little list slice section. Pixels 0:9 is going to give me the first 8 pixels, because it's up to but not including the last number there. And I'm going to make that equal to 1 pixel lower. So it essentially grabs the pixel right in front of it and takes its value. So that's what shifts the colors. And then since we have a gap there between the first and the very last, I grab the initial color there, that first pixel color, and I assign that to pixel number 9. So that meaty section in the middle there, you can actually watch in my serial view here as the colors just kind of wind their way up and they loop around to the bottom thanks to that first and last line there. And then I have a little bit of code here to print out to the serial display. But it's a pretty neat way to, instead of using a for loop or for inside of a range loop, you can, in a very concise bit of code here, move all of these values from a different section of the list to a new section of the list. And so that's how you can use list slices inside of CircuitPython. And that is your CircuitPython Parsec. CircuitPython Parsec. Hey, all right, well, I hope you were able to see that, but like I said, I'm recording these in the background, so when I repost this later. If the captured YouTube stream has gone wacky, then we will have a good copy you can check out later. And let's check out the chat for a second and see what's going on. We've got some Ghostbusters. That's probably something to do with me crossing the streams, right? That's what it feels like for sure sometimes. Good, you saw it. Okay, great. And actually, I'll give you a little bonus tip here, and I might try to add this as a sort of separate topic at another time. But if you check out my code here, let me move that Discord window out of the way. You may have seen when I scrolled down, I have a little note to myself, this little commented out section. This is an even more concise way of doing that same thing, which is I'm saying, let me uncomment that so it's at least got some color. You can see here I can start at my first pixel, pixel 0, and then colon, that -1 or -1 means second from the last item. So it goes up to that last number there, up to number 9, which is the 10th neopixel. And then I can cast that to the whole list. So saying 1 colon and then putting nothing after it, that grabs the whole list. So really concise way to do it. Thanks to Toddbot in the chat for showing me that trick. And I kind of made it into a slightly more digestible for me version at least, which shows a little more explicitly grabbing sections of lists and moving them around. All right. So let's jump back to a main view here. Change that camera out. Yeah, unfortunately, part of what's going on, this is why I'm starting to suspect operating system plus processor plus the software are in disagreement. First of all, the app itself claims that it's using 5% CPU, but my actual machine jumps that number way up into the 80-something%. Which is ridiculous because this is a 16-core Xeon. It's a really beefy iMac Pro, so I'm wondering maybe the best bet might be to roll back my operating system and roll back the version of Wirecast, which is a pain because that means I'm sort of pickling this in time for this one use, and it means other software might start to not work. But let's see. Yeah, actually, someone asked about the system. What's this one? I'm going to check, because I'm curious. Hopefully this doesn't slow things down too much. Let me do the little about this Mac. And that's the case, though. You get a really beefy machine, and then a few years later you think it's really beefy, but it isn't quite as much. Yeah, it's the 2.3 gigahertz 18-core Xeon W with 128 gigs of RAM. There's no way that this should be slow. Software, man. All right, so let's move on to the project I wanted to work on today. So let's let me give you a little backgrounder here first. I'm gonna bring up a browser window here. So I had the topic for this show. I called it Aviation Connectors, and these aren't quite technically that, but it's a bit of a colloquial term used in the keyboarding community for adding these push locking connectors, multi-conductor push locking connectors with quick release on them, to your USB cable for your keyboard or whatever device that you're connecting to your computer. Some people call them aviation connectors. These are sort of a lower cost version of a LEMO connector, which is a really high-end, expensive brand. I've used some similar ones from, is it TC Connectivity? Is that the place I'm thinking of? But these can be expensive. And I've used these for some high-end camera things before in the past, like sort of Steadicam types of things with gyros in them. And a disclaimer, these are entirely unnecessary and probably not even a great idea to use in your USB cables because it kind of breaks some of the USB spec. First of all, a lot of times you'll do these with a 4-conductor connector, which means you're probably not using the shielding. So we also sell a 5-conductor one. I'm not going to bother with that because I don't think this is going to impact my not very fast typing. But you can at least use the shielded cables to use that fifth pin and use the shielded sort of metal loom that goes around the bundle of cables. But really all you'll end up doing is taking a USB cable and essentially cutting it in half. and it doesn't have to be at the halfway mark. But what you'll see is people will make a little short piece, and that plugs right into their keyboard. And then they have the quick release connector that runs off and plugs into their computer. And ostensibly, you can then change out just one end if you're switching to something that uses a different, this is a micro B, but if you have, like, let's say a mini, I love mini, or which you still see on some keyboards, or C, you can just change this end here and you don't have to go reaching around behind your computer. Truthfully, it's just because it looks cool. This is not why people are doing this. I don't believe anyone who says that that's why they're doing it. It's really just because it looks cool. In fact, I'll show you, this often goes hand in hand with coiled cables. So let's do, if I search for coiled keyboard cable, you'll see that these generally have coiled and connector going hand in hand. So here's one premium custom cable. Click on that there. So hopefully you can see that. My connection there was acting slow, so I'm not sure how deep I should go in. There you go. So here is a $44 custom cable with paracord and the wrap and the big chunky connector there. Often these are made with starting from wire, not starting from an existing commercial USB cable, so you'll notice that there's often like heat shrink at one end to cover the DIY connectors. This one's a sort of factory-made one, so it has nice connectors on the ends. But anyway, you get the idea. So that's the goal there, and there's a few different types of those connectors. So we have these, and of course you can use these for a lot of other things. In fact, I think I've still got some here. We've actually carried a similar product for a long time, and I've used these in lighting projects before because they are very convenient when you have a driver board for like analog RGB lighting strips or just for NeoPixels, and you want to connect one end to your lights, go mount those wherever, and then the other end to your controller box, and then you can plug these together. They're keyed, so they can only go in one way. And these ones are waterproof and have little gaskets and little slide-down connectors that you screw in there. So these are a pretty similar idea, but they're not all super stylish like these that we're going to be talking about today. So this is what they look like. These are the connectors. And in fact, I'm going to switch to the overhead view to talk about how they work, how they're made, and what we need to do to actually use them to solder them into a cable. So let me switch to the down shooter now. And if you, let me switch my focus up a little bit. That's decent. So if you look at these, there's a socket and pin end to these, 4 conductors. And you'll see there's these little metal grooves in the casing, which is what keys them. It forces it to only go in one way. So the nice thing is that you can just push and twist, and eventually you'll connect them. So you'll find that spot where they connect in. This one, here, this is a little loose. Let me tighten it up. This one is essentially fixed, the socket side. And then the pin side has a quick release collar that has a little spring-loaded connection, and I think maybe a little ball bearing in there. There's a bearing on this side. So you go, find your twist point, and then you can push in, click, and that's connected really nicely. Now, in working with these, we need to know what pins connect to what so that we can connect our USB cable. So this will be the same with the 5-pin and the sleeving for grounding, for extra grounding, or for shielding really. But I'll show you with the 4 pins. So let me jump back over here for a second. If you click down on the plug diagram, overall length diagram, and socket diagram here, oh yeah, and Vainkyal in the YouTube says it looks kind of like a MIDI cable. Yeah, it's similar. It's not quite so big, but yeah, it's definitely got the feel of like a DIN sync cable or a MIDI cable or even a PS2 DIN connector for old mice and keyboards. So here we get some mechanical drawings here, a little photograph. So here's this arrangement graph down at the bottom, and I determined that that refers to the pin side because, and actually it's funny you bring up MIDI because often when you look at diagrams for how to wire things, it can be unclear, are we talking about the socket side or the pin side from the diagram? If you look at that straight on, that could be the pins, or maybe that's the holes that the pins go into. Thankfully, as long as you're consistent, it doesn't really matter, but since I wanted to get this to correspond to this drawing, they do mold the numbers into the little plastic on the inside once you take this apart. So this is the pin side, and if you look at that drawing there where it's got, let me see, can I zoom in on that a little? If you look at that drawing there where it's got the pin 1, 2, 3, and 4 going clockwise, I am going with, let's find, is this it? I'm going with this type of order for here, since there is a somewhat standardized USB cable order already. So pin 1, 2, 3, 4 are going to be power, data minus, data plus, and ground. And those very often in your USB cables, they often do follow the color coding there, which is nice. So red, white, green, black, that'll be your order on plugging those in. And it will be opposite on the socket side. So that's kind of the key thing to keep straight here, so that you don't make a mess and burn down your computer. So don't do that. So let's jump back into downshooter here, and I'll show you how these come apart. So let's do the simpler side, which is the socket side, right? Yeah. So the socket side, first of all, you'll notice these are nice. They have a little flatting on this part of the housing and on this connector that unscrews here, which means you can grab that with your fingers right now, but with pliers if it gets real tight or when you're tightening it later. So you can hold that flatted part, and then let's see how these are assembled. So this first piece is the socket and the pins that you'll solder to. Set this aside for a second. So you've got these little cupped pins, which means you can feed wire into those and then solder them, and they're as long as you twist and tin some fairly thin cables to begin with, you won't have stray wires shorting things out, but that's the key thing to look for. If you're careful with this, you might not even need extra insulation or heat shrink per wire, but it's a good idea. Another way to deal with that, because on short lengths of wire, you'll often end up heating up your heat shrink while you're soldering. So I like to use Kapton tape to insulate things afterwards. Just feed a little bit in and wrap it around. So those are the pins that you'll solder to. And on the socket side, I'm going to grab a drawing, and I'm going to make a nice diagram of this for people in color, so people can get this straight. So on the socket side, this is the opposite of that pin side. So let me get something to point with. So that first pin there is going to be the pin 4, 3, 2, 1. Is that right? Nope. Yes. 4, 3, 2, 1. Yes, on the socket side, I think that I've got that correct. No, I think I have that opposite. Yeah, from the front side, it's 4, 3, 2, 1. From the back side, it's opposite. So that means that's 3. 4, 3, no, 1, 2, 3, 4. Yeah, okay, so that's 4. Yep. So that's the ground, power, data minus, data plus. And then it'll be the opposite on the other side. So that is our what you'll solder to. So that's kind of what goes on last. So you have to kind of plan this out, because you're going to end up cutting, heat shrink, putting on parts, pulling them back up, soldering, closing them together. So you got a bunch of steps. So that's the first piece in it there. Then these two unscrew. So again, we've got this little flatting here and here. These unscrew from each other. So this is one piece, and this has this little metal collar that will clamp around your cable when you tighten this. So as you tighten this, it squeezes these little clamp flanges here around the cable. So that'll go on before the soldered end. I'm kind of working backwards through this. These come apart, which you may or may not need to take apart when you slide that on, but I'll just show you how it comes apart there and there. There's a little strain relief kind of thing here. Now, to do all of this, we need a couple things. We're going to need either a perfect thickness or diameter of cable, or you need to build it up a bit with heat shrink, which I'm going to show you that with the cable that we're going to use. And you also need to be pretty precise in your measurements, because we need about a 12 millimeter length of wire from here to the point where it gets clamped to. And so you can't strip too much or too little, or you're just not going to be able to get this up over, screwed onto here, and clamped onto the heat shrink. And that's kind of the biggest trick to it, besides tiny soldering. So the other side of this, so the pin side, you can see here again, this unscrews. And this one has this little collar that slides down. So we got to pull that back and then unscrew our soldered pin connector point. You may be able to do that by hand if you grip those little keyed bits that point out there, or you can go. Let me set this down. Or you can go and grab some pliers and do that. Let me lift this up a little to get into focus. There we are. So there, I was able to get a hold of it. But if not, you can use a couple pairs of needle nose pliers to hold both ends of that. Okay, so here is the little pin end and the solder points. And again, it's marked on here. You might not be able to see it too well, but on here it lists the pin out, so you can get that straight. This is all just one piece, but has the little springy, we don't need to pull that apart, collar on there, and then this is the same as the other part there. Okay, so let's jump over to the workbench, and I'll start putting one together. It's probably a little much to do a full build here today, but I will get us going on the basics. So let me just switch where that camera is real quick. Let's double check that. Good, that's looking good. Okay, so I'll grab these actually, and I'll put them sorted together. You can't mix these up, which I've done. If you slide these parts over and then grab this end, you're out of luck, because this isn't going to connect anymore once it's all built, unfortunately. So this is one of these things you've got to do either really carefully the first time or a few times to learn what things are easy to get wrong. Okay, so let me head over to the bench. In fact, first thing I'll do is show you one I got wrong. You'll at least see the sort of starting point of things and can see sort of mid-progress of a build. So this is, let's grab this. Okay, so we'll look at this first. Get some heat shrink out of the way there. That's where that is. Okay, that's about as close as I'm going to be able to get, unfortunately. So here is a cut apart USB-C end. And one thing I've noticed is these USB-C cables, since these are multi-use, they're designed with a thicker power and ground cable than you'll find on your typical USB cable. Because of the USB-C spec, it's meant to deliver more power. So if you're doing this, you're already violating a bunch of best practices and rules about USB. So you might as well use one with thinner cables so that they're easier to solder. It's possible with this, but it's the one I'll start on next is a USB Micro B, where all 4 of the cables are thinner, like 26 gauge or something like that. So if we look here, what I've done, I've cut this and then fed the parts onto here, and I heat shrink this. In this case, I didn't strip this yet, and I might be out of luck as far as where that tubing is and the size. Let's take a look. And this isn't the one I'm going to use. So we want about like that. Oh, this should work actually. Okay. So I'll show you what that stripping process looks like. And I'm just going to take out some of my heat shrink I had on there. So here you'll see these are these pretty thick power and ground, and then these thinner data cables. So what you'll want to do with these is have a very small amount, probably about a 1/2 millimeter is my guess. No, maybe a millimeter, at most 1.5 maybe, because you just don't want there to be a lot of opportunities for these to short against each other. And like I said, if you put heat shrink down here, you just got to be really careful while you're soldering that you don't just shrink it to the ends of the cables here before you're able to pull them back up. So these, you'll give them a real tiny little tip on them there. You can see. Maybe I'll do it on the black one. Might be easier for you to see. Teeny little tip like that is going to be enough, because you can get that into the little cup of that pin end, and then you'll be able to solder that in, and you won't need extra heat shrink. You'll also want to be careful about the little strays that you're kicking up. So that's probably good. So pretty minimal. And then I don't think you'll be able to see much when I do this, but I'm going to put my... Let's see, what if I turn the camera? You might have a better angle if I do it like this. All right, maybe. Let me move this. I've got a little stereo dissection microscope. Am I going to be able to see? Let's see. I don't think this is... Yeah, okay. Yeah, because that's the... See that little piece of tape there? That's the spot I can see. So... yeah, you should be able to see what's happening a little bit. So what I'll do is, on the other one, I'll show you the full feeding on of the parts. But on this one, what I'll do is, I actually don't need this little fan now because I've got enough AC blowing to get the solder away. And then I'm going to use a couple of holders, holding tools to hold stuff in place for me. This one is actually a lost cause. This one already has the wrong end on it, so I'm just going to go with it. This one won't be able to work properly, but that's okay. So if you look here, there's the little cupped ends there, little cupped pins. And what I'll do is actually identify my pins. So this is 1, 2, 3, 4 going counterclockwise from the upper left corner. So I'm just keeping track of where that one is. So that's pin 1, and this is on a pin side. So pin 1 on pin side is going to be red. And so We'll go in here like this, and I'll grab a couple little tweezers. And by the way, a lot of you have eyesight good enough still with your youth that you won't need to have quite so darn many tools, microscopes, and so on to do this, and good for you. But I'm not there anymore. So that red wire is not going to fit fully inside of the little cup that's in there. It's just too fat. But I think what I'll do is I'll just tin the wire, set it in there, tin the connector, and be done. And it'll fit still. I've done this before. So let me get this soldering iron cooking. And I can't quite see the chat from here, so I'm hoping if you're yelling at, hey, you're out of sync, you'll tell me. I don't see any warning. I see a green light on YouTube, which is a good sign. So I'll get in here, pull this away for a second. Whoa, come back. Okay, so I've tinned up the red wire. You should probably go ahead and do all of them, but I'm just going to do the one for now. And I think I'll tin the cupped pin there. And the little shape of that allows it to pool up a little bit of solder as well as to hold the wire in there if it's a wire that fits. Okay, so that's in. And also the pins can actually rotate inside of their holes there, so that's nice because it gives you a little bit of freedom with rotation of this cable with the 4 conductors. So that you can, let's see, can I focus? So that light is helpful at least. About as close as it's going to go. So you can see now, you'll get all 4 in there like that. Then I put a little Kapton sort of between them to separate, especially the red and the black in this case. And then if this were actually the... Oh, did I grab the right side? No. Yeah, because of that mistake earlier, this isn't actually the side it's supposed to get in. This might still connect, though, because I think, yeah, this should just screw in. So you'll wrap Kapton around that to prevent any wires touching the sides, and then pull this up. And that means you're pulling your little clamping section up over your heat shrink tubing, and then you'll get to a certain point where you can start to screw this in. And so you'll just turn this to screw that in place. And you want to turn the part that wants to turn freely so that you're not stripping the wires. So you basically hold the wire side in place and turn the housing like that. And so that can be helpful also to clamp in that flatted section on either of these before you start twisting. So that's what the soldering side is. What I wanted to do now is I'm just going to double check the chat here, and then I'll show you the wire from scratch side, not the soldering side. Let's see. I need a split mirror to feed a camera into the microscope. Yeah, that would be cool. All right, good. Well, no one's saying that we have massive problems. Oh yeah, look, the YouTube thing is saying excellent now. So you got me, man. Nothing changed. I don't know why it suddenly thinks things are fine. All right, back to it then. So let me tip my camera down. Excuse me for a moment while I do this. Pull out a little bit and refocus. So if we're starting from scratch, or nearly from scratch, pretend I didn't cut this yet, but otherwise that's it. So this is a micro USB cable. It's actually one of these neat ones that's not polarized. It's kind of more like an Apple Thunderbolt or lightning cable or like a USB-C. Even though it's micro B, it can go in either way on both sides. Pretty clever. So I cut this. Let's do this side. So now what we're going to do, and I've actually written down steps so I don't go out of order, because it's not good when you do. So strip fabric and outer insulation. So what we want to do is give ourselves a little bit of space for that insulation. And like I said, I measured this out, and it's about 12 millimeters to where the heat shrink starts. So down to about here. And you can do this, by the way, with sort of regular cable and then slip the sheathing from some paracord around it. I don't think I have any right here. There's another way to go rather than starting from a fabric-covered wire or cable. But essentially, we'll trim away here, and then we don't want to bulk this up too much, which I found if you apply heat to sort of melt those ends, you can end up with some bulk that's hard to work around. So what I recommend is just a thin application of Kapton, so that that fabric sheathing doesn't bunch up. Okay, so trim that down. That's pretty good. Go this a little shorter. And then we're also going to, after we apply the tape, we're going to trim back that silicone outer sheathing. And by the way, you may have seen, I've done a couple times on the show before, coiling of cables. And there's a good one here on my camera switcher, actually, so I won't take it off. The PVC cabling works better than this fabric-covered stuff, because the fabric-covered stuff is actually covering a silicone tubing because it's meant to be flexible. And then the individual strands, I think, are PVC, but it just doesn't hold the coil as tight. But I'll save that for after. Save that for another day. Okay, so with that, I'll go and I'm just going to lightly score and twist the silicone sheathing and pull that off. Now I'm going to do a little bit of Kapton tape so that it stops the fraying and allows heat shrink to go over it. Let me grab a helping hand here. Okay, so tape. And I don't want to bulk it up, so I'm just going to use as short a piece as I can manage and still get around it. Okay, so that helps. Hopefully you can see that. I think this light here from the scope should help. Yeah, it's pretty good there. So that should help with the next step, which is putting the feeding all the stuff on. So first piece of stuff we'll do is, let's see, which side will this be? Let's make this the socket side. Sure. So I'm going to separate these out. Stay over there. So let's deconstruct this again. Bonk, bonk. And now this is what we're going to feed on. Again, it's easier to save the stripping of these guys for later so we're not fraying the wires all over the place. So you can see that goes on pretty nicely. If you don't do that, you'll drag that fabric. So this can go here. These guys can join back up like that. This is our little clamping part of the housing. And you can see this is never going to clamp that, and we need that clamping for strain relief. So the magic will be the heat shrink tubing, which goes next. So what I found is there is actually, I measured these with the calipers, and this particular heat shrink we have, this multicolored heat shrink kit, 250 pieces, it's item 4559. This is 0.38 millimeters added thickness. And so 2 sections of it, one larger than the next, that fit inside each other, works really well. You may be able to get away with one heating it and then putting the next over it. I may actually, because I got a nice clean end on there. But either way works. So what I'm going to do is cut myself about, what is this, 20 millimeters. And this one I can do, I want that a little shorter or longer. I think I want it a little longer. Say 25. So I'll feed this first one on, and then I'm going to heat that. So reality check time, by the way. What this needs to do is give us this connection here, and then this needs to be high enough up. Let's keep that heat shrink tubing down. Doesn't want to stay. So this needs to give us, so it needs to be below that point right there. Right. Now have I lost the tubing? Oh no, it's stuck inside of there. This is why tweezers are helpful. Okay, and you can I can eyeball that with one of these. Yes, that should be far enough down. It's like about like that. So this collar can't go up higher than this point, so that should be good. So I'm just going to grab, you could use a lighter, a match, soldering iron. I have a heat gun, so I'm going to use that. Okay, and this is really largely just to add thickness. So this will vary from cable to cable. I wanted to do one that works with these Adafruit cables, but if you have a thicker USB cable, you may just not need the added thickness at all. So let's see, with that, let's see if I can use the same, yeah, maybe the same tubing will fit over that. Okay, and this one can actually be shy of this because the collar is going to get pulled up over there where it clamps. So we'll put that second piece on. This needs to get to basically about 4.5 millimeters thick for the clamping to do its thing. We'll let that cool a bit. Actually, let's measure it. I want to find out if that number is accurate. So yeah, 4.5 and change seems to be thick enough. Anywhere between 4.5 and 5 seems to do it. So I'm not going to, I don't want to come up here with this yet, but that is got just a little space there. It can slide, but that means that the collar, when it comes up here and screws in, should grab it. In fact, let's test that, because this is slightly different than what I did before, so I want to make sure. So I'm over both pieces. If this were soldered on here, I'd be up to about that height. I might need to trim these, actually. Yeah, you know what? I tested on the other. The other one is longer, so my 12 millimeter. Is this the collar one? Yeah, this one comes deeper in. Yeah, I need more on this one. Okay. So The experiment there was with this the same thickness over twice, or the same diameter over twice. I don't like that. It doesn't work. So let's cut that one off and go with the other one that I had before. You can see why Lady Ada says in the product description this is kind of an advanced thing. You got to really want to do this to do this rather than just buy cable, and so it's a bit of advanced cable making. All right, so let's try it with the wider diameter one. I'm assuming that's the difference I need. So let's heat that up over there. The other possibility is that this cable is a little thinner. Actually, that's probably the case. This is probably a little thinner than that USB-C one. So I may need a third layer of heat shrink. I'll bet that's it, actually. Let's see if that changed just using that bigger diameter. I don't know if the wall thickness is the same or not. 4.56, yeah, it's about the same. I don't think that'll do it, so let me just try it. Yeah, it's just not quite enough. It's sliding on there a little bit. So let's, the other method I'd used was I have some slightly thicker heat shrink that Adafruit sells, but I would like to keep it all within one product line. So let's try a third layer of this stuff and see if it's still able to slide up over. All right, here we go. Wish us luck. Let's see if that's... Try it like that. Yeah, I gotta measure the cable thickness we're starting with and see what that USB-C one is. It should be a little thicker just due to those power and ground wires being thicker. Let that cool for a second and check. So this wire to start with is, yeah, 3.39, and the USB-C stuff is 3.6. Yeah, so that's a big enough difference for this. The tolerance is pretty tight. So let's see. I think that extra piece of heat shrink, hopefully, still we can slide over it. That's the if here. It looks like we're getting over it. Okay. That'll do it. So as long as you can slide over it a little bit, then you should be able to clamp on really good when this goes on. And now that's not going anywhere. All right. So yeah, I'll basically put in the guide for this some tolerances that you have to hit, and then it's going to be a bit of work with your multimeter or just trial and error and different types of heat shrink around there. Okay, so with that in place, the rest is what I showed before. So we'll go in, solder this. Once that's soldered, put the Kapton, slide that up, and then you're ready to click into the opposite side and make your little cable. So I hope that's helpful. I didn't want to subject you to doing the full build on camera, because that'll probably take a couple of hours really to do the full thing. But I hope that inspires someone to put these together. Let's see. Let's check out the chat. What's going on in there? People have thoughts, tips, advice. There are some USB cable kits that are being linked on there. Zap cables. Can the cable's outer fabric braid be melted to reduce fraying? Yes. C. Grover asks, yeah, if you If you do, it ends up kind of balling up. This is why I used the Kapton instead, because I ended up with like a little mushroomed bit. You know how when you heat up like paracord, you get that sort of melty plastic rim around it. So you may be able to heat it and then roll it on like a piece of metal desktop or something to shape it while it's still hot. It's a good question. I did that on the first one, and then I found that it was a little too thick to pull things around. Let's see. The audio video quality improved when Lars was in the frame. Yee. Gruesome. Yeah. All right. Someone said they had to make 24 XLR cables in under 2 hours. Yikes. Do you know where the Blinka pink and purple paracord came from? Those are just factory made that way. That was not added on there, so your best bet would just be looking at like a Paracord World or wherever online and getting something that looks close. But that's not a paracord sheath on those. All right. Well, that's going to do it for today. Thanks, everyone, for stopping by, and thank you to the internet for allowing this to actually not break up too much. I think that's going to do it. All right. Well, we will be back on Tuesday, I believe, for the next product pick of the week, and then next Thursday for some more building of stuff. Got some cool new projects on the way. But I hope you enjoyed this sort of more nuts and bolts type of show today. I think I've shown off a couple of the tools and things I'm using before, but I'm a big fan of those little parts trays and some tweezers and helping hands for this kind of stuff. So I'm going to go and put the rest of that micro USB one together, and if I can get the USB-C end, then I'll actually be able to test the theory of just swapping one end, which will be cool. All right, well, thanks, everyone, and I will see you next time for Adafruit Industries. This has been John Park's Workshop. I'm John Park. Goodbye.